Hello and welcome to Rustacean Station. I'm your host, Alan Wyma. Today I have a very special guest. It's Carl Lerche.
Yep.
And he is a principal engineer at AWS, or Amazon at least. And he's also one of the founders, I believe basically the founder, I guess I could say, of Tokio. And so welcome, Carl. Why don't you give a quick small intro to yourself?
Thanks. Yeah, I'm happy to be here. You already gave me a great intro. Carl, I've been working with Rust for 7 years now. I remember I got started well before the 1.0 days, and I definitely remember a lot of the friction from back then, all the compiler errors and the bugs that we hit and the lack of documentation. But I really bought into the promise as Rust and am still here. Besides that, before that, I think I've worked in the Ruby space. I kind of came to Rust from Ruby via the JVM, kind of starting like that high level dynamic programming and then getting a bit lower level each time. If I keep going, maybe I'll end up in hardware next. I don't know, but we'll see.
Yeah, so I believe we were chatting kind of too much before the show, I would say, but it was great to hear all the kind of things you have to talk about, the different topics. And also, again, you've said this many times before, you basically got started, I would say, on this journey of Tokio with Mio, right? I think I pronounced that one right.
Yeah, it was about 7 years ago, and I had my first kid was born, and I had some time off. And I was like, I need a new side project. I don't know, why not program since I'm off my programming day job? What am I going to do? I'm staying up late all night with a crying child, but let's program a distributed database. That was my pick. I was interested in CRDTs back then, so an eventual consistency kind of algorithm. And I wanted to play around with building a database based on that. And so right before that, I was working with the JVM and operating Cassandra. And one thing that stood out at that point was how much time I had spent basically working around the garbage collector in Cassandra. So maybe things have changed since then. That point, I did not want to use a garbage collected language for this hypothetical database, which never actually got implemented. Anyway, that's besides the story. So looking around, there's the common alternatives would be C or C++. Obviously, those come with the memory vulnerabilities. If you look at some of the studies done, if you're using C or C++, something like 70% of high severity vulnerabilities are due to mismanaged memory. And working with any networking services, that can be a bit of a showstopper. I think a lot of the growth of Java within kind of the database sphere, because a lot of Cassandra and other newer databases are using Go, another garbage collected language. I think when building networking services, security really is the number one issue, right? You better to pay a bit of a runtime tax than to be vulnerable, I guess, at when you're in production. But I didn't want to use C or C++. And I was looking around and I had a friend, Yehuda Katz, who knew about Rust. And he said, hey, why don't you look at Rust? So I spent a bit of time looking at it. And I was like, all right, let me try out using Rust for this database. It's not a real project. It's just for fun. So why not try this completely new experimental language that I'd never used before that's not 1.0 yet, right? And I got started, and there was not much of an ecosystem back then. There was the standard library, and I think right when I was getting started was when they just removed because way back then Rust was actually a lot more like Go. It had its own green threads, it had its own built-in async IO runtime that was driving it, but they had just stripped all that. So I was like, all right, let me spend a bit of time binding Epoll to Rust. Let's start with that. And that was ended up being Mio, which originally stood for Metal IO, but now it's just Mio on its own. And started building up that, working on Mio, and I did write a few lines of code for the database, but I did not really come back to that. From there, just kind of started stuck in the networking space, building up that ecosystem. That's how I got started. I guess I could keep going to the Tokyo days.
Well, actually, I'm a little bit more curious about Epoll, right? So
Yeah.
I don't know about the audience, but for me, of course, I'm still getting into systems programming with Rust. So what exactly is Epoll, and does it actually used on all the different operating systems, like the big three I would call
Right.
Mac, Linux, and Windows?
So Epoll is an evented IO system. So traditionally with blocking IO, what most are familiar with, you have a TCP socket, you want to read from it, you issue a read syscall. If there's data, you get the data. But if there's no data, the operating system will block the thread until data is received. So that read call may last in, an indefinite amount of time till data comes in. And that works fine in a lot of cases, but as you're building networking services that need to scale out to like really large number of connections, like thousands, probably more than tens of thousands, the cost of each thread can become a big cost. The context switching, the operating system has to manage the context switching, and it can become a bit prohibitive. So Linux has this API called Epoll, where instead, when you make a read call, instead of blocking the thread and waiting for data to be received, the read call returns immediately and says, hey, I'm not ready. The socket's not ready. There's no data. And separately, there's an event system that you can listen to. You can just block the thread waiting for any event. And eventually the operating system will give you, hey, this socket has now received data and is ready for you to try to read again. So then you get that event, you call, read on the socket, and this time there's data, so the call returns immediately. Now, on top of just like being a bit more efficient in terms of resource usage, there's also the ability of multiplexing a lot of sockets and just a lot of logic on the same thread. And that can also be useful for modeling more complicated kind of logic across multiple sockets. Now, you asked about other operating systems. In fact, no, Epoll is a Linux-specific API. On OS X, there's Kqueue, which comes from the BSD. So FreeBSD also has Kqueue. And Windows has primarily IOCP, which is IO completion ports, which is a very different API. Also, incidentally, Linux is now getting a brand new async IO system called IOU Ring, but I'll just not go into that to avoid muddying the water yet. So there are differences between all the different platforms. And oftentimes when you are using like a library that tries to abstract those differences, that's going to have to make some sort of trade-offs around like find a least common denominator between all of these different differences in APIs. And like something like Epoll compared to Windows' IOCP API are pretty different. So like with Windows, instead of waiting for an event, a readiness notification, you just submit an operation to the kernel being like, hey, here's a buffer. Whenever data comes on the socket, just put in this buffer for me. And then when you're done, let me know that the buffer's been filled. And that's a pretty different pattern. And like figuring out the common denominator can be challenging. With Mio, I ended up making the decision of like, hey, I'm just going to target Linux. It's going to be a zero cost abstraction on Linux. And then we're going to figure out how to kind of unify that on other platforms at perhaps a greater cost. So it was definitely trickier on Windows, but it works on Windows too.
I do have a question, right? Because the Mio, right? It is using an event loop, right? And we always hear that like JavaScript, oh yeah, it's not that great. You can't, spin up a bunch of threads and do things at the same time, kind of single threaded. Isn't this kind of not really performant, right? Wouldn't I just want to spin up a thread for different types of things? Or is that just a bad way of thinking?
Well, yes, I know the JavaScript VM, the Node.js kind of strategy is to have a single thread that multiplexes everything on that single thread. And then for concurrency, you can spawn up multiple like VMs. Like you can have many instances of Node.js running the same application. So concurrency does get tricky when you when you're building networking services. It's definitely a valid strategy to do that, to have like fully isolated shards that run on a single thread and don't talk to other kind of threads and each thread does its own work. And that has some very attractive like characteristics when running, as it really you avoid the overhead of synchronizing threads. But you can then get into situations where each thread does not become balanced. So each thread is doing different amounts of work. And to avoid that, you have to be extremely cautious about how you are balancing work across these threads and ensure that they stay balanced. There are Tokio provides kind of a bit of both, a blend of both, with a work stealing scheduler where as much as possible, all the work stays on the same thread. But when a different thread becomes underutilized, so the one thread that you're running runs out of work to do, it takes work from other threads to rebalance it. And this is so while it has a bit more overhead in terms of thread synchronization, the synchronization overhead is greatly minimized. Go uses this same strategy. And I think the Tokio blog post has the Tokio blog has an article from 2018 or 2019 that outlines how Tokio learned from Go's scheduler and borrowed a lot. So a lot of implementation is shared, I guess, like the strat algorithms, right? Obviously, you can't just take Go, copy and paste it, but a lot of the algorithms are shared between Tokio and Go.
So then you could say that Tokio is actually using some type of green threading or coroutine kind of
way? Yes, you can. With async Rust, you have the concept of a task, and that is similar in idea to a thread or to a coroutine, right? But with async await, you can write your logic in a step-by-step one kind of way. But the compiler at compile time will take that kind of almost synchronous logic and rewrite it to be a state machine that can be then multiplexed. So that once it's compiled to the state machine, then Tokio or any other async runtime can take all of these tasks and the scheduler can execute them on a single thread, because at each task, when it hits a quote unquote an await point, is going to yield back to the scheduler. And that gives Tokio the opportunity to run a different task. So I think green threads is an overloaded term, I guess. A lot of people might think that's something like Go, where you don't think about await points, but there are a lot of similarities.
Okay, so they're actually implemented slightly different. There definitely is some shared thinking.
So Go uses green threading, which means there's a stack. It maintains a stack. So each Go routine maintains its own stack, right? And when you hit a yield point with Go, it's got to jump out of that stack, which is the compiler handles all that for you. And that stack is maintained as is. So that stack will look almost identical to a thread stack, right? So one thing that is challenging with async Rust and the state machine approach is that implementing something like recursion, because you don't actually have a stack, gets challenging. With Go or any more, I guess, traditional green threading strategy, recursion will just work as you expect.
Okay. So we talked about Epoll, we talked about Mayo, right? What was the next step to go one step above that, right? Was it that Mayo was maybe a little bit too low level for people to really get something going, or what was their thought process?
Yeah, Mayo was a bit low level, and I started experimenting with futures independently, and it's still on my GitHub. If you look for Eventual on my GitHub, you'll see my original experimentations, and then there's Eventual IO, which was very early thinking of how to bridge Mayo and futures. But the kind of idea is yes, writing at the Mayo level is very low level. So how can we go up from there? And futures is one way. I think that's promises in JavaScript, but that general strategy of using the future abstraction to model async execution definitely has history and prior art. Separately, there was I think Aaron Turon, Alex Crichton were interested in exploring futures as part of Rust. I guess from their point of view, they also like this was a point in time, I think, where there was like a Rust survey of like where should we focus on, and focusing on server libraries was top of the list. So building out that ecosystem was a priority for the Rust core team. And eventually, like they built the futures crate, and I abandoned my eventual experimentations. And for initially, we started working like together on the Tokio implementation. So it was a joint effort initially. I continued to maintain it longer term, but the idea is just like how, from that point, like how do we take futures and make async IO programming with Rust as easy as possible? And there's a lot of discovery on how to do that. And where we landed is definitely, I think, not where I was originally expecting. But in the early days of Tokio 0.1, everyone was essentially writing their futures by hand. And writing a future by hand is, if you look into the internal implementations of Tokio, you'll still see it, but it's a lot of manual state machine, like nitty gritty around like sequencing logic. And it was definitely not easy to use. And one of the biggest points of feedback from users of early Tokio was, it's really nice that it's fast, but this is really hard to use. So I think from that point, that was when the Rust core team or the Rust language team started exploring adding async await to the language to kind of make that, to remove the need for users to write those state machines by hand. And it's definitely there was a lot of challenging aspects to it and like unsolved problems, specifically like how do you provide a safe zero cost async await notation? It was early on, it was very unclear how to do it. And I didn't follow the exact details of like the iteration of the development, but I know Without Boats did a lot of work there. And I think Boats like pioneered the pin idea, like how to like the pin abstraction. And that kind of unlocked async await and unlock the ability to have a zero cost async await while maintaining safety. And it's like, I have to say, it ended up way better than I expected going in. Like hearing all the challenges and the difficulties of actually building async await with Rust, I was like, well, I don't know, good luck. And while I know pin has its issues, right? It's not the easiest concept to learn when you are working on async await, and then all of a sudden with Rust, and then all of a sudden you see pin and like, what is this? It honestly, I think like it ended up really well, and you know you have to give kudos to Boats and whoever else worked on that, because I think it turned out pretty great. There's more work happening right now with the async, I guess, vision. Like Nico Masakis is kind of leading that, and watching that as well. I think there's going to be in the future there's opportunities to remove all as pretty much pin from 90+% of users writing async await. There's ways to do it. So hopefully in the future, no one, unless you really dig down into the internals, will end up seeing pin. And that should hopefully greatly improve a lot of the ergonomics.
Yeah, I saw pin, but I just couldn't quite wrap my mind about like what would be the reason for ever using this. So you're saying it's mostly for async await?
It was initially what it's for. So it's for async await. You need to create data structures that are self-referential. So this data structure points to itself, has pointers that points into itself, and that was not possible to model with safe Rust beforehand. So using pin, it now is, which is pretty great, I think. I think down the line, hopefully, async Rust is going to be getting easier and easier. It's definitely a learning process. Like you come from something like Rust that's like really low level and is trying to figure out how to provide all these APIs and libraries that you would expect in a language like JavaScript or Go, but without the associated overhead of like a garbage collector or like, and while maintaining safety, like that combo of safety and performance, I think is going to have a lot of long-term implications, and we're just kind of getting started there.
Okay. Yeah, so I do remember playing around with Tokyo quite a while back, and one of my first thoughts was, what things do I use from Rust, and what things should I use from Tokyo? Because it's
Yeah.
like a lot of things are duplicated, but I guess it's because you have to
Yeah.
be able to smoothly work with the runtime, right?
Yeah. There's definitely, well, the easiest answer is if you're using Tokyo, use all the stuff Tokyo provides. That's the easiest answer. There are like more subtleties there. I think long term, it is still unclear where things are going to land long term. Maybe Rust will end up adding a runtime internally. Maybe it won't. But I think figuring out how to smooth that onboarding experience and those confusions around what's the standard library, what isn't, is a focus for the next like 3 to 5 years. So, like I said, like I think Rust started from a point of view of like, we're going to be a better C and C++. Like we're going to, like, it's going to be a systems language. And then as things evolve and people discovered that Rust can actually has the potential of being a much easier to use language, like let's push it out into places where like you might not need Rust. Like maybe Java, Go, and all that is really good, but Rust's characteristics around performance and also something that's like something that's also important to me and a lot of other people, but like sustainability. Like so there's another aspect of using Rust besides just performance. It's that you can serve more requests if you're writing a networking service with a lot less energy, and that's an interesting. Like I learned recently, it's like my intuition, for example, of like, okay, well, yes, we use like we write software, but like it uses energy, but like how much, like it that doesn't measure much compared to like cars, right? But I saw a study recently where something like data centers use something like 4.5% of all global energy, like grid energy, right? So it's data centers and software you write use a measurable amount of energy. So a thing that's becoming interesting to me, and that's also guiding a lot of what I am thinking about, is like, can we make using Rust as easy as possible so you can use it in situations where you might not need the performance, but can we even make it like easier to use than other options? Because then if you do use it, even though you might not need the performance, you are going to be like more like you're going to run a greener software. I don't know. It's like you will end up using less energy and lower carbon emissions, right? Because while each individual piece of software might not matter that much, like everything put together is significant, right? Even like 1% is going to be significant. So that is something that I've been thinking a lot more about, I guess, well, recently and over my like more recent career.
Yeah. I also heard something similar. So, and that's also what kind of brought me over to Rust, is that when I wanted to, I do want to do things faster and easier, and no matter what, all these VM languages, they always have some kind of cost to them, no matter how quick they are. I'm still working with Python right now in a project, and that's been the most painful part. And also wanting to spin up threads and do things a little bit quicker, it's been a little bit painful. So I've been looking at bringing Rust into the mix.
Yeah, because I know historically, like I said, I did a lot years ago with Ruby and Rails, and performance was always kind of like a hot topic. And I know kind of like the line back then was like, well, like hardware is cheap, like software developers are expensive, so don't worry about performance, worry about like optimizing developer productivity. And that is true. Like that is very true. Relatively speaking, like not many people, not many organizations, or not much software is ever going to hit the kind of that tipping point between like software, like I guess infrastructure, like the cost of running it, and developer productivity, right? So performance might be nice for customer experience. I mean, it's very nice for customer experience, but that like tip between developer productivity and operational cost, not many orgs tip over that. But when you think about it from a sustainability point of view, we all need to kind of like take a step back and like, well, is this wasteful approach sustainable in the long term? But the flip side is I don't think we can ask developers to give up on that productivity side of things. So we have to, within the Rust ecosystem, and I think what's interesting too is like the Rust ecosystem is really focused on, dare I say, micro optimizations. Like, let's really get the last bit of juice out of this bit of code. And to be honest, like I have been like guilty of that plenty of times as well. But instead, like, even if like, can we take a different point of view and like, well, can we focus on ease of use and getting to the point, like maybe it's not apps like 100% as fast as it can be, but maybe 99% as fast as it can be, but you gain all this productivity and ease of use on the other end. And from there, can we get to the point where Rust is an attractive option just to build like software with in general, not just your most critical performance sensitive software, but like most software? Can we get to that point? That's something, I don't know, that's just something I've been thinking about as well recently. So I bring it up because I also hope that other Rustaceans might hear that and think about it as well, and maybe start a conversation about that.
Yeah, I think that's the nice part about Rust is that you can have that high performance code, but still with a high level way of programming. And I think that's really the beauty of it. Plus, you don't have to worry too much about safety and freeing memory to a certain extent. I mean, of course, there still could be leaks. Mm-hmm. It's not 100% safe from that, but for the most part, most things I think will be caught, right?
Yeah. There's a lot of it thanks to the like Rust ownership model will let you, like the drop, you can do a lot of work, a lot of cleanup work in drop implementation. So whenever value goes out of scope, you can make sure everything's cleaned up. Leaks are actually pretty, I don't think I have personally ever hit a leak when I wasn't doing really unsafe things. And, while I probably have written more unsafe code than I should have, like Tokyo's internals just fundamentally need to have some of that. So I try not to write unsafe if I don't have to anymore, though. So anyway, I've not hit many leaks except when I did something that I probably should have.
It's usually what I hear, actually. I don't really cause leaks unless I'm doing something I shouldn't be doing.
Yeah.
There actually is something else I'm kind of curious about is, do you feel that there's kind of a little bit too much macros coming more and more into our code every day? And let me just say this, it's because I'm looking at so recently I'm trying to get more into ActiveWeb because I'm really thinking to replace some services. And I have a macro, of course, above the async function main. You guys do the same thing. And I see what he's expanded to, like, why don't we just expand it rather than having to make this macro on top?
It's a good question. Well, let me step back and ask you, what do you see the cost of the macro as being?
I mean, I do like the macro, but the thing about this is that, it's becoming more unclear about what it's doing, right? That's the thing that's the way I look at it. It's kind of like the unknown. It's not implicit. Or is it implicit, right? It's not very clear what it's doing.
Yeah. I think that is true. I would call it like a hidden dependency, perhaps. Like you are doing something and you're not sure what, like, does it, so if it does work, why do you care what it's doing? Let's step back about that. Like, so you do something, you put a macro and you're saying it's the fear of the unknown, which is very legitimate. But if it was just doing some work kind of like self-contained and you got the output that you cared about, like a normal function, you call a normal function, do you have that fear of the unknown there?
Well, the way I look at it is that if I don't know what that thing is doing and I do have a bug or a problem somewhere, then so I do work for clients, right? So if my client says, what's going on? And I'm unable to explain that, that's where my kind of fear comes in necessarily.
Yeah, I think it's interesting. There's, on one hand, I agree with you. On the other, macros do give you a lot of power. It's going to be a question of striking that right balance, right? So, for example, Rocket uses macros heavily as part of its routing API and its like just general API. And personally, I do like it. Like, so the question is then going to be like, some are like, okay, so you have the macro. I'm guessing it's trickier to understand what it expands to, is what you're saying. I mean, would you feel the same way if like you could take in your IDE, you could have the IDE automatically expand the macro for you at any, like just be like, expand this macro so I can look at it and then unexpand it?
Yeah, I think that would be nice if my IDE could do that. I think there's a cargo expand which could actually output what it does expand to.
Right. So cargo expand, as someone who has authored many non-trivial macros, I have to say like cargo expand has been an invaluable tool to see what it is, but it is definitely not as usable as I would like. Like what I would like is like maybe, like I said, you have a macro in your IDE, you just be like expand it one level, right? Because one problem is like you expand one level, then you get the next, you lose the print lines. So if you have a macro that writes out print lines, then if you do cargo expand, it's going to expand the print line as well. So maybe like what you'd want is like, okay, let's have a macro. I have a macro. I have my ID can expand at one level. And then you could like select another macro and be like, expand that one kind of thing. That would be, I think, helpful. So let's hypothetically say you had an ID that did that. How would you feel about macros then?
I mean, my point is that I just want to know what it's doing, right?
Exactly.
I'm all up for macros, right? Yeah. And let's kind of go back, right? You and I both had Ruby. We both did Ruby quite a few years ago. You could just crack open a class and do whatever interesting stuff you want to do and close it, and you don't know what's going on. So, but I think that's another extreme, right? I don't think you're going to have something like that. You're not going to use some function and it's going to be doing something else with Rust, but still, you don't know what some of these macros are going to be doing. And so it'd be good to figure out like, okay, what's exactly doing? Because let's go back to Tokio, right? You actually, in the documentation, you do talk about what that macro does. Enable all. Well, what is it actually enabling? Can I turn off some things? Or like, that's the kind of questions I have.
Yeah. Yeah. And oftentimes you just want to look at the source, I think. And product macro source is definitely not something you can just glance at. So I would think, so there's a documentation problem, like as well, like what are the arguments you can pass into it? And then there's an expansion problem, like understanding what it does. I empathize with your feeling of like macros at a level, like just generally they feel complicated and scary to use. I don't understand them. That is legitimate. I don't want to throw out the baby with the bathwater, right? So macros are really powerful and you can build some really nice things with macros. They have drawbacks today. One, if you get the macro wrong and you get compiler errors, usually they're like unreadable. Like I have no idea what's going on, right? There's an error inside of the macro generation. That doesn't help me. So you lose error messages and it is difficult to know what the macro does because when you look at the macro source, you see all this syntax parsing and stuff that's just unmanageable. So perhaps like if you could assume a situation where macros were purely functional, because right now you can make like arbitrary HTTP calls or whatnot. And then you could like say they're purely functional. You could expand them nicely inline just to see what they're doing. And I guess better documentation. That seems like something that seems like you'd already get pretty far at removing, quote unquote, any potential hidden dependencies there. So you could, if you wonder what it's doing, you could see what it's doing. You could just see the expanded code. I don't know what to do about the just jump into it and read it. I think that is a open question. How can that be improved? I don't know. That would be an interesting thing to look into, but I don't want to throw them out. Yeah.
In no way am I against macros, but I'm just thinking like the one that starts up the main, like I just look at it and I'm like, does this really need to be a macro? Because I think it's quite clear. I think people new to Rust maybe would prefer the macro because it kind of abstracts the nitty gritty. But other than that, like I think it is nice to see this thing, right? Like so Tokyo Runtime Builder, new multi-thread. Is there
Mm-hmm.
other things I could be using for the builder?
Well, yeah, hopefully the docs pointed you to the builder and then you could see the docs there. Yeah, it'll be, I think there's a bunch of usability, like just digging into the details of the like developer experience there is, especially for newcomers, is something we're like higher, coming from higher level languages, whether Java, JavaScript, Ruby, whatever, um, is something we should put some focus on. Again, I don't think throwing out macros is the answer, and I think used appropriately, they are quite powerful. But I agree that improvements are needed and I think we can get to a point, hopefully, where you can just see, like, you can remove the fear of the unknown with macros.
No, I in no way am I against macro. I love the derive debug. I love the
Yeah.
derive serde deserialize. I think that stuff
Yeah.
is fantastic, right? But I just worry that too much macro can make things very complicated. Like you said, I've had issues where maybe I typed it wrong and then it just
Yep.
blew up, and you're like, what the hell's going on?
Yeah, I agree. That, I mean, in general, I think that should be fixed, and I think that could be fixed. So yes, that is an area that we should put in some thought. Maybe I'll harass Esteban some more. Everyone's super busy is also the thing, right? It's like where it's a relentless exercise in prioritization.
Yeah, I agree. Okay. Yeah, so I'm definitely enjoying so far my journey with Tokyo, and I used another project. I was pretty happy with it. I am kind of curious though, like the overhead that this would add to a binary, is that like negligible, you think? Or is it, because it is providing a lot of stuff for you, right? Is there tree shaking involved also?
I mean, that all depends on your requirements, right? So are you constrained by binary size relative to like shipping a JVM? It's going to be small. You can. It is so. Tokyo is focused on being able to strip anything you don't want to. So, like for example, if you use Tokyo and you really, really are resource constrained, you can opt in for the feature flags. We separate all the different bits of functionality by feature flag. So you can start by just opting into what you want. Like if you don't want the multi-threaded scheduler, just don't enable it, and none of that code's going to be there. Separately, the link time optimization is going to be able to strip a lot of the dead code. So if you take an aggressive, like if you do aggressive link time optimization, you will get even more benefits from there. That said, my guess is like a lot of binary size isn't even going to be stuff like, I mean, it's hard to say. It'll be some Tokyo, but like you'll get things like debug strings, right? So like every time you have a debug output, debug implementation, you're going to have those strings are going to be embedded in the binary. And if you have tons and tons and tons of types, all with debug implementations, that's going to cause binary growth, which is, I think, actually one reason like some crates make debug implementations a feature flag so you can opt out of it. I think that if it ever gets to the point where it is the binary size of Tokyo itself is at a point where you are unable to reduce it to something that works for you, that is a point where you can file an issue. And either we'll look at that being able to run Tokyo in all these more like resource constrained environments is something we want to support. So like I don't think if it comes to a trade-off between like, if it's either like a binary, we can do this, but we have to sacrifice something else, then it might not pan out. But usually it's not that. Usually we can either help you figure out how to reduce the binary size, or like create a change that will support your case.
We had a long discussion about macros, right? And I think in the end, like macros, they provide. I think what would be a good summary for macros if you were to say?
They provide the ability to express more in a more terse like form factor. You can express, they give you a lot of power, but right now there are some usability concerns, especially around when things go wrong, error messages are really bad, and macros kind of open a box for doing like a bit of anything. In fact, that reminds me, it was that David, David of Axum in Tokyo just wrote a macro that makes HTTP requests during compile time. So that is an interesting experiment. I would not recommend it, but it opens that kind of box, Pandora's box of anything can happen during compile time. So I think the future is going to be with macros kind of figuring out the happy medium and the sweet spots and improving error messages and improving visibility and transparency into what the macros are doing.
It's a little bit scary, right? If you're doing something that's making HTTP requests, but it could be kind of useful too if you're like pulling secrets and want to put them in compile time.
Yeah, I would not recommend it. I think if you want to pull in secrets at compile time or things that you need to pull in at compile time, a build script will probably be better. Like you have a build script where it's clear, where you see the HTTP request and it generates a static file, and then you include that. I think if it were me, I would prefer macros to be entirely sandboxed, and there was some talk around that with macros being compiled to WASM and then using like WASM, like a whatever, WASM lets you sandbox, really provides a lot of capability for sandboxing. So if the macro were compiled to the WASM, you could just feed in the ASTN, get out the tree, that transform tree, and that's it, and like prevent HTTP requests. So that would be interesting. But right now it's not sandbox. You have everything there. And since we're talking about it, I believe, wasn't there a security, it wasn't actually implemented, but someone realized that there are risks to having macros that are unsandboxed and that you can just pull in a crate and it will, during compile time, run arbitrary code. So there are potential risks there with untrusted code running where you wouldn't expect it, but as of now, it's not been exploited as far as I know.
Now people know. So maybe you might get some people.
Yeah.
It's a little bit scary. I did want to kind of get back to Tokyo 1.0, right? Or sorry, to Tokyo itself. Obviously, 1.0 came out quite a bit of time ago. As far as I know, it's still, it's in terms of stability, right? Within Rust, like things come out and you can use them for like as long as whenever, right?
Mm-hmm.
But like, so since 1.0 came out, it's not like you're putting your feet on your desk and just saying, okay, let's just, let it ride and just do. You guys are actually doing stuff, right? So what's kind of like going on since 1.0?
Yeah. So since then, there's been a lot of small incremental work in terms of adding APIs, cleaning up internals, like polish, like lots of doc writing, more guides. And Alice, who, if you've been on the Tokyo Discord or GitHub issues, you will see she does a great job in like a lot of this maintenance. In fact, like Alice is probably the most active contributor to Tokyo, like day to day. But besides that, there's a bigger effort to improve Tokyo and the general like Tokyo stack. So Hyper and Tonic and all these other libraries to make it easier for developers to debug their applications and to like have visibility into the runtime characteristics of their application as in production. So that means like metrics, exposing in data on the Tokyo scheduler, like how many tasks are queued up, or is there bottlenecked on, or is the scheduler bottlenecked on too many tasks coming in, or is it mostly idle, or maybe tasks are lopsided, so there's not an even distribution of tasks. Maybe there's like one really expensive task that is taking up all the CPU time, and all the other tasks are kind of just being scheduled across other threads. But these kinds of questions are what come up when you're operating the application. So it's after the initial development, like you've got something running and you want to see how it's operating. You want to debug it in production. You want to debug it like in dev time too. That is kind of like making that story better is the current focus. So on that front, there's Tokio-console, which is still in an early developer preview kind of state. It's not quite ready for GA, but it's definitely usable already. That effort's being led by Eliza, again, the Tokio core member. So the idea of Tokio-console is right now it's just a terminal UI. It's you have your Tokio app, you run it, you enable the console, you open your console, and it starts right now like a kind of like top for tasks. So like if you're on Linux, you type top and you see all your processes, like the state of the processes and what they're doing. You'll see the same thing for your tasks. So if you have a server implement Tokio, you'll see like, oh, there's my listener task. These are my my connections. And you can see like maybe a task is hung and you want to know, well, why is my connection not responding? So you can open up Tokio-console, look at it, and it'll show you, oh, here's my task. This task is processing this connection. Open it up and see, well, it's currently blocked on receiving from this channel. So this tool will let you get greater visibility into your application and help you debug it faster, basically. So it's still very early, but if you have an app with Tokio, a service, whether you're using Hyper or Tonic or anything with Tokio at the core, I would strongly recommend to try out Tokio-console. And related but similar is we're going to be building out like an API to extract runtime metrics, like I kind of hinted at, so that you can export those to whatever metrics aggregator you're using. So Prometheus, or just dump it to a log file. But if you want to see what percentage of time is spent on waiting in Epoll versus processing tasks, you'll be able to get that and export it however you want. So general incremental stuff, plus the short-term big feature is improved visibility. Now, long-term, the work is going to be less on Tokio, the core runtime. It's already pretty stable. So what's next? And I think my interest and where I think a big potential area to focus on will be looking at developers building, web apps or services or like basically API endpoints, and look at that problem not as let's build a router and let you hook up the endpoint, but more like from an end-to-end kind of experience. So my history is, I think I mentioned this, I started doing a lot with Ruby on Rails. And what I really liked about that is that it was it's opinionated and it's full stack. So you don't have to worry about which database library you're going to pull in. You don't have to worry about, which back then, I don't even remember mailers and active support and all these kind of battery utilities that you had to pull in. You didn't have to worry about that. You just use Rails and it was an opinionated experience. And now I really like that. I like the idea of an opinionated full stack experience. So what would that look like in Rust? It would for modern service development, and it's going to be something quite different than what Rails is, obviously. But right now, if you want to build a service, you have to kind of navigate this landscape and figure out which crates you want to use for databases, which crates you want to use for queues, which crates you want to use for exporting metrics and for your router and for gRPC. And it's kind of a disjoint landscape. So can we kind of look at what most developers need when building a service, even if it's a microservice or something that's just backing a JavaScript application, and look at that kind of as a entire end-to-end thing and build something that covers the full experience, I guess. So that is going to be the long-term direction, kind of growing the Tokio stack to be more batteries included and opinionated there. So there'll always be the runtime, the Tokio runtime, which is its standalone thing, kind of like that you can use. It doesn't care what HTTP framework you use or doesn't care what you're doing. But then what does the greater Tokio stack look like? Can that be more unified, coherent, and batteries included?
So Tokio has now expanded its definition to run past the runtime to, like you said, batteries included, kind of full-on framework.
Yeah, well, so it'll always be a different crate, I think. So there's obviously like this, like right now there already is an idea of a stack, but it's the set of libraries like Hyper and Tonic and Tracing and whatnot. And maybe instead of having these as disjoint, there'll be like one crate that unifies them all, kind of thing. It probably won't be, it'll probably have its own name. I don't know what it is yet, but some product, like some kind of crate to fit that space.
Okay, because right now if you go to Tokio.rs, I mean, you see a bunch of different projects, so it gets a little bit confusing when you're just thinking about the runtime itself.
Yep, exactly. So then the question is, should the runtime be its own crate? Probably, yeah. Where's Rust going to go itself with async? There's the Nico has been kind of driving, Nico and Tyler Kramer have been driving the async vision, which is kind of trying to figure out where Rust itself wants to go with async. And there's no decisions there, but I don't know. There's opportunity to streamline the overall experience. So developers that want to just build something and not worry about having to not worry about all the decisions of picking your right crates and learning about the trade-offs. And does this one crate do exactly what I want? Do I want to use, kind of like all these tiny decisions that end up being bumps to getting something done, right? I think there's a lot of opportunity to streamline that, to smooth that out and get something that's just this is how you do it. It might it's opinionated, and if you disagree with his opinions, fine, you can use something else. But a lot of people just want to be told how to do it. If I just want to be told how to do it, it'd be great if I didn't have to worry about it, kind of thing. I've always liked having a lot of decisions made for me. I'm not actually that opinionated. It's kind of like if I'm using a programming language, I don't care what editor I use. Just tell me which IDE is best for it, kind of thing. So I've always I used Vim. But when I dabbled in Clojure, I was like, all right, Emacs is what I use. I'm not a Emacs versus Vim. I'm just say whichever works best. And I actually now use Visual Studio Code more, simply because it's just more batteries included. I don't want to have to. I don't like all the time that I had to spend configuring Vim every single time. I know some do, but that's not for me. I'd rather be more productive with what I'm really trying to do.
I kind of want to go back to the Tokio-console, right? Because that's kind of a really, I want to say revolutionary, but not necessarily revolutionary, but it's really an awesome idea, right? So looking at this page, it got started from, there's a couple of things I see in here. One is there's a mention about 2019 Google Summer of Code project, and then there's also a mention about implementation of TurboWish Tokio-console. Where did all this stuff come from?
So this really came from, years ago, just seeing users of Tokio building applications with it and just being back then, one really annoying problem that came up often is just tasks got deadlocked, because this was back before async await, when you had to implement your futures by hand, basically implement the pull method. And if you had a bug in your implementation, a task could just stop running and deadlock. And you're I have no idea what's going on. My app just stopped running. Is it a bug with Tokio? Is it a bug in my application? I have no idea. So that was all right. So back then we were thinking, how can we solve this problem to help users debug why my task is deadlocked, why my app is deadlocked. Why are my tasks not responding? So that was the original idea. And back then there was so much to do. So it didn't get a lot of resourcing. I think it did start as a Google Summer of Code where we're all right, can someone basically do this? Let's try this. We applied for Google Summer of Code. And there was a good initial work, but it didn't reach kind of like that escape velocity into a full project. And that in part, that was because it was still very early on in Tokyo, like that was well before 1.0, and tracing was just getting started. In fact, like one of the original ideas for tracing was to be able to enable something like Tokio-console. So that like being able to power Tokio-console was a kind of requirement for tracing during the design. So from there, then we joined. I joined Amazon, and so did a few other Rust developers. And our goal was kind of like, well, the same realities apply. Like people are building applications with Rust in Tokyo, and they're hard to debug because you can't. It's hard to use a traditional debugger because usually the symptom is my app stopped responding, kind of thing. And the question is why? Well, there's no stack where you can attach a debugger and just be like, show me the stack, show me the variable, show me like the backtrace. You don't have that. So the idea with TurboWish is kind of like our code name for the project that covers tooling to make debugging and performance profiling easier. So TurboWish is not an actual project. It's just how we're referring to this effort. So like one thing, at Amazon, one was we're just Rust developers from the community. It's like, we've been around before we joined Amazon. We're just continuing on. So we're going to be working on, we're going to be contributing to ecosystem projects. And instead of just having it was just easier to refer to one thing for the effort. So, and separately, Eliza wanted to build, Tokio-console as well, because she was involved in these early discussions as well. So she just, kind of did it in her spare time, which is awesome. And we're trying to coordinate, Sean is chipping in, and Zahari, and there's a bunch of other contributors. So we're all working together to try to get this into as good of a tool as we can. And I do think that what's interesting is that when we released this, I think one of the main thing, one of the bits of the responses that stuck with me was someone said was, when I saw this, I just kind of assumed that JavaScript had an equivalent one, because how would I be coding without this? But then I looked and there isn't. I was I thought it was interesting how, well, JavaScript has some really good tooling, but nothing quite like this. And I think that is in part due to Rust's asynchronous model. Rust async model is different than JavaScript's or any others. So with JavaScript, you mostly have, an async process and a callback originally. And that was then async await was added as sugar on top of that. But Rust's async model is really based on the concept of a task. And that task is quite similar to a thread, but because it's smaller, applications tend to group their logic in terms of tasks. So you have this natural unit of logic that kind of is fundamental, I guess, in the application. So you can instrument that, and by just bubbling up tasks, it's even better than just bubbling up threads. You're actually bubbling up units of logic, if that makes sense. So it turns out to be Rust's async model is conducive to these kinds of debugging tasks, debugging tools. And I'm very interested to see where the community goes with this, because I think we're just starting to scratch the surface of what Tokio-console can do. And that's we started with a terminal UI because that's easier, and none of us have UI chops, but I don't see a reason why there couldn't be a nice web app even, or a GUI, or go even beyond what we're doing here.
Yeah, it would be, I don't know if all the how to hook in the instrumentation is documented yet, but that would be something I would be interested in kind of playing around with. Because I like to use IntelliJ. So if I had a sidebar where I could just click on a button and it would just kind of pop out, that would be fantastic.
Yeah. Yeah. And what's interesting, like I said, it was all based on tracing. So to get the level of visibility into the application that is needed for something like Tokio-console, you need to expose all that data, right? And tracing was really that hierarchical, structured logging framework. It was while it was positioned as that, it was more the intent was more to be a way to export the necessary data to really get rich insights. And something like Tokio-console was in our minds when we were working on that design. So I'm glad to see that all that, like, it's been a lot longer in the making than I was like initially hoping. Like back when we were originally talking about Tokio-console, be like, we'll get everything done in 6 months, not a problem. It's a few years later, but it's finally coming together.
Even though it's kind of later than what you expected, but it sounds like it's definitely something that you're like, okay, this is good. This is going in a good state, right? That's what I feel like when I hear you.
Yep. I think it already solves some good problems. So there's a lot more we want to do with it, but it's already exciting to see people finding value in this. Like it's already quite valuable, and we see people using it and being like, "What this is what I wanted," and that's very it's very exciting, and it helps. It's motivating to get that feedback.
And then this would be something that we would just, it shouldn't be a problem, like maybe not now, but in the future, where we could just leave this thing kind of open so that we can always hook into this.
Yeah. So even though it's like called Tokio-console, or it's actually just console, I don't know what the name's going to stick or not, but it's not tied to Tokio in any way. Any runtime can use it. So to use it, the runtime just has to export, just has to use tracing to export the necessary data. And I think Eliza even implemented a proof of concept version for Rayon. So I think Eliza, I think she probably forked Rayon and added the necessary tracing instrumentation and was able to get Tokio-console working with Rayon. So any runtime will be able to use the console, like the Tokio-console, as long as they use tracing to export the data.
Okay. And my previous question was just saying, like, we could actually have this on production in the future and it wouldn't be an issue. It's not just for debugs only.
Yeah. So in production, it'll probably look a bit different. I imagine what will probably happen is that there'll be different levels. So tracing already has the concept of levels, and you're not going to want to export every single bit of data in production, but you will be able to get some of it. I think we're going to have to end up benchmarking and see the overhead and then decide the right amount of data to export in production. But yeah. Or instead of just you don't have to use console. Again, it's the key point is you have the libraries, the runtime and the libraries in your application are exporting the data via tracing. You can then hook up a completely different tracing subscriber and just dump the data somewhere else, like in logs or in X-ray, like a distributed tracing, or a Zipkin kind of thing. There will be ways, you could just implement a tracing collector that exports a Zipkin or something and get the data there.
Wait, so is this, I was trying to understand how this thing works. So it's actually into the same binary that you're running the tracing on, right? It's not like you do a cargo install and then you would just connect. Is that correct?
No, you have to pull in, I think, the tracing subscriber. Let's see. For console, you pull in the console subscriber, and then it just kind of like how you with the env logger. If you're using a logger, you do logger init. You would do console subscriber init. So that pulls in the instrumentation side of console, which console subscriber is just kind of a layer on top of tracing that normalizes the data. So once you do that, then you can connect to it with the console UI.
Okay, so I would have to maybe cargo install some kind of console UI and then connect.
You have to cargo install the UI, I believe. I'm not 100%. I would guess so. I don't know if we're 100% there yet. Looks like you may have to just clone the repo and do cargo run right now, but eventually there'll be a cargo install.
Got it. So I do have one more question about this. This is kind of related in terms of if I switch channels and all that kind of stuff. So if I cargo install things, they always stay there, right? Even when I do a Rust update.
Yeah. So this is not my area of expertise. I believe cargo install installs those whatever you're installing to not into your application, but into a system global. It's probably actually scoped to you, the user, but somewhere that you can use from your terminal anywhere. But those crates that you cargo install are not part of your application, right? They're just a way to get tools or whatnot. It's just a different way to get tools.
Okay. I could just imagine this being like a cargo console or something, and there would just be like how you have cargo add, remove, edit.
Yeah, we were talking about maybe having some like cargo console, like a cargo extension, like cargo console that does everything all at once. Because right now you have to like run your application and then start console on the side and then connect it. So there's some opportunities there to smooth it out. That's down the road.
Okay, sounds very exciting though. I would like to actually go back to now the Tokyo ecosystem, right, that you were talking about. This is like really, like we talked about before, a little bit confusing, right? So then you were talking about before the stack, right? So I'm just kind of going from top to bottom on the website. So the stack is kind of like the Tokyo stack is what you were talking about with all these different pieces coming together. Then you have the runtime, which is just called Tokio.
Yeah.
Right? And Hyper.
Yep.
Okay.
There is we need to do some work on the messaging and presentation because like I think there is value in having the concept of a stack that is a set of libraries that are built to work together, that are known to work well together, and that's as well as eventually like a batteries included, really like opinionated structure on how our flow on how to use it. But there is some overloading when that we call it the Tokyo stack. And that is like, what's the difference between the stack and the runtime? Yeah. So there's opportunities to improve that. I will agree with you.
Yeah. Also, I mean, it also could be a little bit misleading because like, let's say you're not doing something with HTTP, but you are doing heavy IO. Tokyo obviously would make sense to go into there, but Hyper maybe will not unless you're actually doing HTTP, right? Or same with Tonic, right? And everybody uses gRPC.
Yep. Yeah, I'll get back to you on how we will improve our messaging and presentation.
Okay. For Tower, right? So I've heard a little bit about Tonic, right? We talked about that. And it looks like Tokio-console is using Tonic as a way to send some messages. I think everybody knows about Hyper, but Tower is kind of a little bit newer concept. So like having retry load balancing, that wouldn't be something that I could just do myself, or does Tower really give me a lot of power?
If you're familiar with Finagle, or Tower is aiming to be something like that. Or like, for example, if you're familiar from the Ruby side, Rack, so Ruby Rack, there's that abstraction between servers and the application, but only for HTTP. Tower aims to be something like that, but for any protocol. So it's generic over the protocol. And there is like Tower HTTP that is a specialization of Tower for HTTP, and like Warp and Axum both use it. Now, the core of Tower is a trait called a service trait that is essentially just an async function of request or response. So you could imagine that if Rust stabilizes an async function trait, we could just get rid of the Tower service trait in favor of that. But for now, that doesn't exist. There's also so Tower is being worked on, but I would not recommend it yet for everyone to use. And part of that is because there is, in Rust right now, there's not a great story around async functions and traits. And like I said, Tower at the core aims to be an async function trait. So right now, to use Tower, you have to do the old style, which is you have to implement your futures by hand. And that is not as great as I would hope. So my hope is soon, like end of the year, sometime next year, there'll be a clear path on when async functions and traits will get stabilized. And when that happens, we can do an overhaul of Tower to make it more friendly and usable to all. Now, again, I think Tower might be more interesting if for a Tonic author. So like if you were building something like Tonic, or if you're building like an HTTP framework like Warp or Axum, what is good about Tower is that all those reusable components you can take off the shelf and you can use them and decorate them yourself. So if you're building like some RPC protocol or a framework like that, that is really where I think Tower kind of shines. Kind of like if you are familiar with Rack and Ruby, like most users would use something like Rails, but Rack provided this opportunity to like really grow the ecosystem. So Rack for Ruby was important more for the ecosystem than the developer writing their applications. And Tower is kind of like that. So that is to say, like, for example, Buoyant, my previous employer, who's building, they're building a service mesh, which for me, like, I'm not deep into the cloud native space and the Kubernetes space, but generally, like, a service mesh is like a really fancy application level proxy. So for them, something like Tower was really useful because they needed all those individual components to pull into their service mesh. And Buoyant is able to, be quite productive with Rust by leveraging all those components. And they've contributed components as well that are now we can use it in Tonic. So it's really, I think, about the ecosystem level. Tower's about the ecosystem level more than for the individual app developer.
Okay, that makes sense. Kind of keep going through. I mean, is it Mio or Mio?
Yeah. Mio, Mio, cool. MIO. Yeah. I've heard everything.
Yeah, tracing. It's pretty clear. But I think Bytes is also interesting too. Like, why did you guys decide to get into Bytes?
Bytes is a utility crate for byte manipulation. So it gives you, there includes some traits for working with byte, kind of like a byte array specific specialized iterator trait. So it gives you an abstraction for a container of bytes. Then it also gives you a few implementations. So I've been wondering, bytes probably is a different level than like all the other crates. It's more of a utility. It's like, if you're familiar with Rails, it would be nice if we had like an active, is it active support or action support? I think it's active support, right? Which is just a set of utilities that are really useful. So right now we got bytes. I think we're going to eventually over time, like as we really focus on the developer experience, the end-to-end developer experience, we're going to be making sure we got other utilities covered. So that might grow. I might, looking at this, I might not include bytes at the top level. It's a nice utility. Maybe we need a name for a bucket of utilities. I don't know. But if you're doing network applications, bytes is going to be very useful for you. Like almost everyone uses it.
Okay. All right. I think we used quite a lot of your time, and I know you're a pretty busy guy, so.
It's been fun. I really enjoyed it.
Yeah. I think, when the console comes out, maybe it'd be nice to do a deep dive with you or somebody else to kind of talk about like what it exactly does, kind of the nice features about it, things like that.
Yeah.
Or anything else going on in the space. Is there anything you wanted to talk about before we sign off?
I think we covered most of it. I would love to have like Alice and like Eliza come up and talk about what they've been doing too. Like I said, Eliza's been really focusing on Eliza and Sean have been really focusing on console, and Alice has been doing a lot of the day-to-day of Tokio. So it'd be great to have her to come on too.
Yeah, please, if you can do the introduction, I would love to have them on.
I'll do. Yeah, I will. But yeah, it's great to be here.
Actually, I just have one last final question. Like, do you find that somebody made a comment previous episode saying like, because they're using Rust, they find it easier to have people be interested in working on their projects. Do you find the same thing with Tokio?
So in general, I've definitely heard like Rust is like Rust can make, development easier and more productive by reducing bugs. And a lot of people feel like one, thing you hear a lot with Rust is like once you write once, you're confident it's going to run, right? Because it's very misuse resistant. So that is hard to quantify, right? That is, how do you quantify like the number of bugs that are written with Rust versus another language? But there have been studies that based off of surveys that show that is a common sentiment. And I kind of believe it. I think there's, with Rust, there's a tax you pay up front, but once you pay like the learning and generally like the initial like laying out of the structure of your code and all that, but once you pay that tax, you get a lot of benefits afterwards, right? So your code is more reliable, refactoring is easier because of a rich type system. It runs faster, There's, less operational work because it just like like a lot of, downtime oftentimes comes with, oh, I have like a concurrency bug that has only showed up in production, or, oh, actually this GC ran at the wrong time and it caused a cascading failure. A lot of those issues just don't come up with Rust. So it's hard to quantify, it's hard to quantify how much in practice, but engineers who have done both Rust and other languages consistently say they are like, in the long run, they are more productive and efficient with Rust. So I guess the answer is yes.
All right. I don't want to push my luck and ask for any more questions.
I know. I'm happy to come back as well.
Okay. Well, let's give it some time first, because we got a lot out of you, and I can't imagine there'd be any changes for the next couple of days, which would be good to have you back on for. Plus, let's give some time to the other people you mentioned, right? So.
Yep. Let's do that.
All right. Thank you again for your time.
Thanks. Have a good one.
Thank you so much again.